All right, ladies and gentlemen, this is going to be our photosynthesis video, and we're going to be looking at an overview of photosynthesis. So let's get started on this next video. So what is photosynthesis? Well, photosynthesis is where autotrophs produce high-energy carbohydrates into sugars and starches. And plants take the energy from the sun and convert it into chemical energy, which we are going to go through and generally call glucose. So if we think about this, we're taking carbon dioxide, and then we're going to take water molecules, and we're going to go through a chemical reaction. Now we're going to use sunlight as a source of energy, and we're going to use the chloroplast as the organelle to complete this photosynthetic reaction. And when we go through this chemical reaction, we get C6H12O6, which remember is a carbohydrate, and it's glucose. And then we're also going to get oxygen as a byproduct, oxygen gas. So photosynthesis is for autotrophs, remember, animals that produce their own energy. And we're going from light energy, energy from the photons, to chemical energy in the form of glucose. So how are plants and animals using energy? So remember, if we look at this cell, we have to remember we are going through and looking at the mitochondria and the chloroplast here. They are the organelles that will be producing the energy for plants and animals. So plants are going to have leaves, and these leaves are going to be used to capture photon energy from the sun. And the sun is going through and generating energy via these photons and beaming it down on Earth. Now inside the plant cells, they're going to go through and capture this energy using chlorophyll and using the chloroplasts. Chlorophyll is the pigment that the chloroplasts are made out of, and then chloroplasts are what are going through and generating the chemical energy. Now plants are going to have inside the chloroplast these thiacloids, and they look like little tiny pancakes. And this is where the photosynthetic reaction takes place. So the chloroplasts are taking sunlight and energy from the photons and converting it into chemical energy. And this chemical energy is going to be in the form of glucose. Now, glucose, if we're comparing it to lipids, is really short-term energy storage. But here's the thing. Glucose is longer storage than compared to the other molecule that we use in our bodies, which is ATP. So now if we look back into the cell, we're going to have chloroplasts and mitochondria in plant and animal cells. And remember, mitochondria are taking the glucose, and they are going through and taking that longer-term energy storage and converting it into really short-term energy storage, which we go through and call ATP. Now, ATP, the reason that we don't use glucose as the main source of energy is because ATP is used for very, very short-term energy. It can be regulated and it degrades quickly. So the best way for us to go through and store energy kind of in that happy medium, that Goldilocks zone, is via glucose or these carbohydrates. But plant cells and animal cells are going through and they're taking the sunlight, converting it to glucose, and then shipping it to the mitochondria to be converted to ATP. Now, if you are a heterotroph, well, you are going through and consuming all of those other organisms, either plants or animals, to get your glucose. So if we're looking at an overview here, we have to think about it this way. So we have sunlight, and this sunlight has energy via the photons. And that sunlight is captured via the chloroplast and converted to chemical energy, which we call glucose. Now, that glucose is then shipped to the mitochondrion, and the mitochondria will then convert it into ATP. And ATP is what is going to allow the body to quickly release that energy. So we're going from light energy to chemical energy that's stored in that glucose, and then to chemical energy that's released very, very, very quickly via that ATP. So if we're thinking of storage of chemical energy, we're going to have lipids, which we've already talked about. And lipids are going to be for really long-term storage of energy in plants and animals. Now, if we're thinking about kind of short-term energy or somewhere in the middle, well, short-term energy is going to be from our carbohydrates. And that's going to be like where glucose is. And then when we're thinking about really short-term energy of storage, energy that we can use almost immediately if we need to, well, that takes place via ATP. And we can see this hierarchy of lipids, carbs, and ATP, and they're either more or less stable dependent upon what molecule they are, and your body or animals and plants can keep these molecules based on their chemical structure. Now, there's a variety of different organisms that are going to utilize photosynthesis. Obviously, we've been going through and talking about plants, but there are also going to be multicellular algae that are going to go through and use that. These are some algal fields in California. We can see these kelp forests, and they use photosynthesis to generate glucose and products in their cells in order to stay alive underwater. There are also going to be unicellular eukaryotes that are going to use these. So there's a variety of different protists that will use chloroplasts and use photosynthesis to generate energy instead of consuming food. We're also going to have cyanobacteria and purple sulfur bacteria. And they appear these colors because of the pigments present in their cells and within the chloroplast. Now, purple sulfur bacteria are going to use a slightly different pigment to capture light energy, and we'll delve into this a little bit more in class, and then we'll discuss it when we get to chlorophyll and chloroplast pigmentation. But there's a variety of organisms that utilize photosynthesis in order to maintain homeostasis and stay alive and make sure that they have energy in their bodies. Now, when we think about this, we can harness this energy for our own use. Unicellular algae are going to be really prolific producers of plant oils. Now, cars and automobiles and the way that we get a vast majority of the electricity in the United States is via oils. And simple chemical processes can yield what we call biodiesels, which can be mixed with gasoline or used alone as fuel. So these oils can be burned, and that's what we call a biofuel, a fuel derived directly from living matter or living material that can be used in place of a fossil fuel that we are using now to go through and generate electricity, move cars from place to place, or go through and transport people via the air or via trains. So biofuels are a really, really new and exciting field in biology and in chemistry because it yields lots and lots of different ways for us to harness energy. So growing these algae and then producing more and more and letting them reproduce in these fields and then harvesting the oil out of these algae can go through and replace fossil fuels that already exist on the electrical grid and then for automobile and plane and train use. And it's an exciting new field that has lots and lots of job opportunities. They're well paying, and they allow you to go through and be very creative as to how you can go through and create these chemical processes to make them efficient and make the world a better place. So, did you guys learn? Well, did you learn a couple of things? Did you learn what photosynthesis is? Did you guys learn the overview of photosynthesis? And then did you guys learn about biofuels and renewable energy? This is going to be the end of the video, but we'll see you guys in class tomorrow.